Hey everyone, I'm Brady Volpe, founder of the Volpe firm and Nimble This. Welcome back. This is a second part of our special edition on cloud native virtualization. Back with me is Asaf Matatyaou, Vice President, Solutions and Product Management, Cable Access Business Unit at Harmonic. Asaf, so glad to have you back.
Thanks for having me back. Looking forward to our discussion today.
Yeah, so Saf, what's up with you? What's new? What's been going on? And also, where are you broadcasting from? I'm not sure we covered that last time with you.
Sure. I'm broadcasting from San Carlos, California, in Silicon Valley. And like most people, we're still surrounded by different predicaments of 2020 with COVID and the unfortunate fires in the area. I hope everybody's staying safe and healthy. But of course, that leaves us at home consuming more and more internet, and we're just about to blow through our monthly quota, which has been increased to almost 1.3 terabytes, and apparently that's not enough for my household.
Well, that's as interesting that you say that because that I think leads nicely into our topic today of virtualization and what we can do about that and how it impacts us. And we'll get into that in just a moment. But first, I'd like to shout out to our audience members. Please do talk about what you like, and if you're watching, please do hit the subscribe button and also click on the notification bell if you want to be notified of future episodes and also when we do our uploads. So into the show, recap from last time on virtualization. We did talk, Asaf and I, about what virtualization is. We talked about virtual CMTSs. We talked about cloud native virtualization. If you missed that episode, check down in the link to this episode and you can catch up on what the last everything we talked about last time on cloud virtualization. Asaf, I don't know if there's anything you in particular you want to cover that we talked about last time. Otherwise, we'll be catching up on new topics here.
Well, thanks. Yeah, that's a good refresher. I always think that it's worthwhile mentioning. Virtualization sounds like a very fancy and future word, and it's worth repeating and saying what the state of affairs is, at least in our industry, in the cable industry in particular. And if you don't mind, I just want to remind folks, what have we done over the past few years, and how much progress has been made in this area. In our experience at Harmonic, we've been deploying virtualized software-based vCMTS solutions since the end of 2016, we have millions of devices connected to our solutions globally, from the smallest operator in the world, from the smallest operators in the world to the very largest. And there's been a lot of public announcements and rollouts and volume in different sorts of environments, from centralized or traditional infrastructures that have analog infrastructure in their HFC, to DAA and fiber deep and everything in between. So really, virtualization is a great foundation for doing many things, and I know we'll spend a lot of time talking about that today. But it's also something that's very mature, and has been deployed for a number of years now. So we're just tapping into the power of virtualization, and let's see how far we can go when you start with virtualization.
I think that's actually a good point that you bring up because we're talking about virtualization almost as if it's something nebulous, something that hasn't happened yet. But to drive home the fact, virtualization is something that's real, that's happening out there. And personally, we have Nimble This, the software side of the company that we have, has many customers that are running and deploying virtualized CMTSs. And as we look at it from a P&M, a proactive network maintenance standpoint, when we deploy our software solution on a virtual CMTS, it looks exactly the same as a as a hardware-based CMTS. So the two solutions basically look identical when you're monitoring those from a monitoring platform standpoint. So I think that's a really good point, basically, that you're making. Virtualization's real. It's being deployed today. It's working really well. It looks identical to the hardware component, and that's
It's an
basically what I'm
interest.
saying.
Yeah, absolutely. And I think that was table stakes. To start with something new, you have to give operational familiarity, and that operational familiarity is first of all how to use the product. What's your interface to it, whether it's CLI or SNMP or IPDR, which are the different sorts of configuration monitoring tools that are tried and true in the cable industry. That being said, we also have a lot of more advanced tools that provide streaming telemetry and orchestration for configuration that give a lot of benefits that are above and beyond, the baseline table stakes that are there. So again, you have to be able to give that familiarity to start with, which gives that parity of experience. But now you could look at, hey, what more can we do with this? How many more you know what are the benefits around and leveraging virtualization, and there will be a time and a place where CLI and SNMP will be left behind because they're older and maybe they aren't as advanced and don't provide the richness of experience that you could potentially gain from all the newer tools.
Yeah, and I just want to take a moment to throw out definitions in case some people may not be familiar with what CLI is and SNMP. CLI being the command line interface. And for a lot of us who have been accustomed to working on CMTSs or maybe even a Linux server in the past, so a CMTS CLI would be just getting down onto this command line terminal, like maybe you've seen hackers working on in the past, and on the virtualization side, maybe Asaf, you can say what a CLI looks like from the virtualization side of a CMTS.
The CLI is a CLI. It looks the same. Syntactically, I mean, there's really no difference in terms of the CLI. It's still a command line interface. It's still a human being typing commands. What could you do with a virtualized approach is you can take it and make it orchestrated. You can automate it. You can provide an API. You can have intelligence in terms of being able to scale the configuration aspect of your solution, and not just depend on a human being typing commands. And really, that's where you need to go if you want to be able to have scale of deployment.
Yes. And then SNMP was the other term you threw out. SNMP, Simple Network Management Protocol, is a
Yeah.
programmatic way that we can get information or communicate back and forth with CMTSs and also cable modems using a very simple management protocol or very simple language. So when we normally communicate with a hard box CMTS, we send commands using SNMP, and the CMTS will send the data back that we want from it. Say we want to know the power level that a cable modem is sending back to the CMTS. We can just communicate to that CMTS and say, hey, what power level is that cable modem? Or what's the SNR or MER of that cable modem? And a hard box CMTS will give that right back to us when we query that. Asaf, how's that work with a virtualized CMTS?
Well, that works identically. So if
Exactly.
somebody's using SNMP, you send an SNMP get message, as is basically saying, "Get me the SNR," as you example you get, and we will send the data back. In a virtualized approach, you could also use streaming telemetry, which is not using SNMP, and that gives us benefits where, first of all, it's a much more efficient protocol. You're able to get a lot more metrics, so the quantity of metrics and the I would say the period of the metric. So traditionally, and Brady, I can ask you this in the tools you're familiar with. How often do you do an SNMP for a particular piece of information? In my experience, it's like once every 15 minutes or four times an hour.
Yeah, I mean that's typical. Just because when you do query a CMTS using SNMP, it creates a load on the on the CMTS or the cable modem as well. And
Hmm.
so you don't want to do it, you don't want to do it every second or every few seconds or anything like that, because it creates additional load, and that load can also impact subscriber data, because typically the main focus of the CMTS is sending subscriber data back and forth, routing that information, etc. And so additional SNMP load is going to impact that subscriber routing.
Exactly. And one of the interest, and of course, between those, so if you're measuring SNR every 15 minutes, the SNR can go up and go down between those measuring those points you're
Mhm.
measuring, right? So you really get a snapshot every 15 minutes, which is good. But a much better way of looking at things is getting a much more continuous stream of that metric, because things can happen in those 15 minutes.
We get a lot of
Um,
bursty noise and that burst
mhm.
noise may not show up in those 15-minute intervals.
Absolutely, right. So if you use more efficient protocols and you're able to transmit more information more frequently on the order of a few seconds,
Mhm.
then it gives you that perspective of what's really going on in your plant, and it doesn't have to be just SNR, but there are other metrics that we can observe. So that's what we mean by streaming telemetry, is being able to do that in a way that provides much more insightful information over the course of the period of time you're monitoring your solution. So yeah, so you obviously, as you mentioned, we can support SNMP, but then you have the opportunity to do streaming telemetry.
Right. So I'd like to start off with a question that we had from our last episode from one of the readers, and it says, "I wish the SOF could have elaborated a little more on the server to RPD interface." So we're
Sure.
talking about, I think, what we call the CIN, right? So that's how
Yeah.
the CMTS talks down to the RPD. So the reader's asking, or the watcher was asking a little bit how that interface, how that communication works between the virtual CMTS and the RPD.
Yeah. So a traditional HFC infrastructure where you have an integrated CMTS has everything, the RF generated at the head end, which then goes to a transmitter, and you have your analog optics out going all the way out to the optical node. So your plant is mostly um, analog optics and RF over that, right? When you're going to uh, what we're talking about is using digital fiber and Ethernet or IP to transmit information between the CMTS core. In our case, it's a virtualized CMTS and the remote PHY device. So two things are happening there. One is the RF is not generated at the head end or the hub necessarily. It could be, but it's generated where this remote PHY device is. Okay, and between this RPD, whether it exists in an outdoor enclosure 100 miles away or it's sitting in a rack, the interface between these virtual CMTS servers, these off-the-shelf servers, and this device generating the RF is just an Ethernet link. And we use standard-based remote PHY protocols that are DEPI. They're DEPI, UEPI, the D and the U standing for downstream and upstream. So DEPI, UEPI, and this protocol GCP. It's Cable Labs specifications, and that gives interoperability. So you could use different vendors' RPDs with different vendors' CMTS cores, whether it's a traditional integrated CMTS core that supports remote PHY, or in our case, we use a virtualized CMTS core running on servers. So the connection is it's IP over Ethernet running over digital fiber between the servers and the RPD. And if you don't mind me expanding on that, Brady, I will just say that gives us a great opportunity, because we're going from something that was, I would say, very cable centric, very specific, which is RF over an HFC infrastructure, to something that can be connected to different sorts of access technologies. When you have digital fiber and you have IP running over it, you can do a lot more. Um, you can run different applications. The possibilities are much grander, and they expand much more than just cable. You can, fiber to the home, PON, talking about wireless. Those are all things that can interconnect much more simply over this digital fiber link running
What
IP.
what so you said it's an Ethernet link. What is the speed of the Ethernet link? Is it like 100 megabits? Is it a gigabit? Or is it even faster than that?
Yeah, it's today we're running 10 gig links, and you can run multiple 10 gig links, and we have these switches called the DAS switches, which stands for DAA switch, or distributed access architecture switch, and it's an aggregation switch because you can have a bunch of 10 gig interfaces going to each one of these RPDs, and so it's a lot of capacity, and there are going to be, and as you heard probably in there were some great light reading next gen cable event sessions in the past couple of days that talked about going to even faster links, and there will be faster links, but right now the technology is 10 gig links going to these RPDs.
Okay. Um, so there was, I think you kind of alluded this, and there was another question from last week's episode that says, let me find the question. Asaf could talk a bit more about Volt, and they said Cable OS supports that when the HFC node becomes a remote 10G PON node. So I thought that was kind of a nice concept. Maybe you can elaborate a little bit more on that.
Sure. Yeah. So Volt stands for virtual OLT. Um, Sometimes you'll say virtual PON or VPON, but Volt is a good way to think about it because OLT is kind of the analogous sort of device as a CMTS, right? So I guess PON is to DOCSIS as OLT is to CMTS. A virtual OLT in this case is going to be if we think back to what we talked about last time, if you have a cloud native infrastructure platform, um, then you can have different sorts of workloads or applications running on this cloud native platform. The one we talked about last time was a virtual CMTS or vCMTS workload. And that workload lives on this platform that has basically different sorts of services that can be shared across other workloads. So a Volt workload or a virtual OLT workload can sit on the same platform right next to a vCMTS on the same general compute servers that then can communicate over this digital IP link to a remote OLT device out in a remote PHY device. And you can imagine you can have this remote OLT living on its own. You can have it living next to basically an RPD, and you can have multiple capabilities and functions that could be served out of this remote enclosure to your DOCSIS customers by outputting RF, and to your PON customers. And so it really gives us a new term, this multi-tenant capability on top of a cloud native platform. Multi-tenant meaning multi-purpose, multi-applications. And in this case, we're talking about multiple access architectures living on the same platform. And it's great because this shows you the power of being able to scale different services on the same platform based on need and demand, but sharing the same infrastructure. If you think about from an infrastructure point of view, maybe file system storage, monitoring, unified configuration, those are powerful things that you could look at by generalizing on a single cluster of servers or multiple clusters of servers that are actually monitored in a unified way, depending on how you'd want to deploy it.
Okay, so
A lot of things I covered there, Brady. So you might want to
yeah, no, I'm gonna start
dive.
breaking them down here. So
Yeah.
we have the CMTS, and actually this could be a virtual CMTS or a standard CMTS that connects to what we said is the CIN. CIN is
Hmm.
if I'm correct, converged interface network.
I think it's interconnect, but I confuse it all the
Interconnect.
time. So maybe I'm
Yeah.
wrong.
We'll have to look into that one. But anyhow, that is basically an Ethernet link to where we have the RPD, the remote PHY node, and that link is an Ethernet link that you said is 10 gigabit, and I think I've even seen those up to 100 gigabit in speed, in really large deployments, or so I've been told, maybe incorrectly. Um, So now we have, instead of having what we traditionally had is an analog link, where we had a forward path transmitter going out to an analog node and a return path transmitter going back to a return path receiver in the head end. We basically totally eliminated that analog portion of the system and replaced it with this, what we call the CIN. So now we're all digital from the head end to where our nodes are. Correct.
Hmm.
That's correct, right? Totally correct on that.
Exactly.
And so that the benefits of getting rid of analog and replacing it with digital, I think you could summarize.
Well, yeah, I think, and I think you can add to this, right? Is first of all, there's lower cost. I think the digital fiber is lower cost. It's higher speed. It's longer distances, more wavelengths, and ultimately, it also gives you a higher signal quality, so you can transmit faster speeds. Um, so if you're thinking about DOCSIS in particular, you're shortening the amount of cable you have and the amount of analog influence on the SNR. So you're just leaving it to the very last little bit coming out from the RPD just down to the subscriber itself. So all that means is we could send more bandwidth to more customers.
Yeah, and then from an RF perspective, like I see getting rid of, we don't have laser clipping, we don't have some of the traditional issues that we would have with that analog portion of the network once we get rid of it. It's a digital link, and so with the Ethernet links, that's, I think, a much, it's a it's a much better controlled network from in
Hmm.
terms of noise. If we have to repeat it or send it over longer distances, it's always a much more clean signal, much more robust signal. So the
Absolutely.
yes.
Lower
Um,
main, and then ultimately it's lower maintenance costs as well. If you think about labor and other aspects of operational expenses for dealing with those types of infrastructures.
and that's just because you, from a lower maintenance, lower labor cost, because we have less components. We're not dealing with cleaning, or dealing with cleaning connectors on analog lasers, dealing with the
Exactly.
maintenance cost of analog lasers, higher reliability on digital links overall.
Exactly. And
So
and also from a physical connectivity point of view, I think that you could think about aggregating a bunch of Ethernet links versus RF cables at your head end, right? Less patch panels, less splitters, less combiners. So there's also a space wiring savings aspect to it. You can aggregate Ethernet links a lot simpler. You could take a bunch of 10 gig links and aggregate them to 100 gig links. So there's a lot of space, power, cooling, wiring
I was going to ask about
savings.
powering. Is the powering and cooling on Ethernet less than analog transmitters and receivers?
I don't know the
I'm
answer.
going to tell you the answer is
Do,
yes, but
yeah, yeah,
it is substantially less.
yeah.
um, so okay, so now we have this digital link going out to the RPD, and this is where you started talking about that could support an RPD, or we have a 10 gig digital link going to maybe an not an RPD, but actually being able to drive fiber deep and putting in an ONT or something like that into there. So that I think is interesting from a cable operator standpoint and what they could do. And when we talk about COVID and how COVID could suddenly change an environment to where, right to one day all my office employees are in a big office building someplace, and then suddenly later now all my office employees are in a suburban area or working from
Hmm.
home. So I think that offers a unique solution for operators, that they could pull out an RPD that's sending RF signals, and then drop in an RPD that's sending optical signals out. So could you maybe elaborate on that more, how that change out could happen from RF to optical?
So there's a few thoughts that I have around that. First of all, I think that COVID hopefully will go away soon, but the impact of it, I think will be forever changing in terms of the way we consume data and how we do things remotely. What does that mean? I think that folks will more regularly work from home, study from home, get healthcare from home, and the types of services we get from home, I think, are impactful on the upstream. It's not just about consuming more video, but also video conferencing all the time, for example. And I think that allows people to also understand that they don't necessarily have to work if they were close to their offices before. If they can work from home, maybe they don't want to live where they're living right now. So I heard recently, that there's going to be some more pressure on rural um, internet consumption, an increase in those types of services, right? Smaller service groups, and basically having efficiency of how can you say, smaller deployments, but more of them. There's potential for that. And what does that mean? It means we have to be efficient, whether it's a small deployment, many small deployments, or or large deployments that are centrally in one location in one facility. And the good thing about this architecture is that we're able to address both of those types of deployments with one architecture, right? When you have a general compute, you could decide where you want to put it. And when you can use that general compute for either a RF or a DOCSIS based deployment, or eventually just fiber to the home, and you can uh, select which one is the right deployment in your footprint, especially if you have mixed footprints. That's an opportunity that's worth looking at, especially when you don't need purpose-built or custom hardware. You could think about, in the past, you really had to silo those types of um, products that you're picking, whether it was a hardware-based OLT that lived in a facility, or a hardware-based CMTS. If you're able to run those sorts of virtual OLT or virtual CMTS applications on the same cloud-native platform, on a general purpose compute, then you have that flexibility in determining what's the most appropriate type of service that goes to your home. And at least for me, the determining factor, fiber to the home is great, but there's still labor associated with it, and there's different criteria of when and how that gets deployed. Obviously, that there's going to be a lot of motivation to get to fiber to the home over time as well. But it doesn't take away the fact that we have this infrastructure for DOCSIS that is ubiquitous and exists, and isn't going away anytime soon. So
Yes.
those two things will have to live together.
Yeah, and as you said, we all hope COVID will go away soon, but I think the impacts that the changes that we've done in business are not going to go away, and that was covered a couple of times on the light reading panel that was happened this week, where people people did talk specifically to that, where businesses are saying, uh, whether when and if COVID goes away, or when COVID goes away, the work flow is going to change. Meaning, their businesses are already talking about going to a different work methodology, that people will return back to an office, but it's probably going to be more of a shared office, where I go back to the office space for 2 days a week, and then someone else shares that same office space for 2 different days out of the week. So I think a lot of people are changing the way that we're looking at the new work environment in the future. It's not going to be the
Hmm.
same as the old work environment, which means a lot of us are going to continue working from home. And we've seen some graphs where the new traffic model of having peak hours between 7 p.m. and midnight, now those peak traffic hours are pretty much all day long, because
Yeah.
children are learning from home, people are working from home. And I think that's why I think it's interesting that we have these new adaptabilities in our network to be able to drive fiber deeper. And also, with RPDs, we just have much more capacity with DOCSIS 3.1, and moving forward with DOCSIS 4.0.
Yeah, and I know we have deployments where RPDs are even daisy chained, right? So you can have
How's
one
that
fiber.
work? That's interesting.
Yeah. So, well, I mean, you have at least with harmonics, we have various types of RPDs in different form factors, and the way we designed our RPD, it has three SFP plus interfaces. And that gives us opportunities to do multiple things. One of the things we can do is we can daisy chain RPD, the first RPD to the second RPD, so you don't have to run fiber all the way back to both RPDs. Now, obviously, they're sharing the 10 gig link,
Mhm.
but nobody's actually consuming 10 gigs right now, so it's a
Right.
reasonable thing to do. So you could share that and do two RPDs or three RPDs daisy chained to each other. We actually looked at the third SFP plus interface as an opportunity to have this remote OLT pluggable as well. So you can imagine the output from this RPD One is a daisy chain to a second RPD. Then it outputs RF to the cable modems, and then it'll have another pluggable that pushes out a PON signal to ONUs. So it gives quite a variety of footprint support and flexibility over there. Yeah, it shows you that first of all, fiber is very important, and having uh, you can't discount in some cases that you have fiber shortages, and you want to be efficient in how you use those the fiber.
So I'm curious. I can like I live in a neighborhood that has one entrance, and but there's a couple hundred homes in it. You can't easily serve that with one RPD. You could, but I could see that being a scenario where you could come in and daisy chain. You have a fiber coming in, but then you could daisy chain multiple RPDs in a neighborhood in order to give everyone uh, you know really good quality signals from the standpoint of a MER, SNR
Hmm.
standpoint, because pretty much everyone in the neighborhood could be directly off of an RPD then. Is that kind of vision for that concept?
That's one use case.
It's one use
I
case,
think,
yeah, okay.
yeah, it's one use case for sure. So yeah, I think you can think about different use cases where you want to have multiple MAC domains or service groups, or in the case of PON, multiple remote OLTs, but you don't have multiple fibers running back all the way to your DAS switch. So if you don't have it if you don't have that amount of fiber availability there, then this is an opportunity to share that fiber across multiple RPDs.
Okay, makes sense. Edge compute, the term has come up multiple times, but it's sort of a nebulous term of, what really is edge compute? What does it mean?
Yeah, honestly, I think that we're yet to find out exactly all the different applications that are going to be around edge compute, but we know that when we drive and leverage the compute for ultra low latency sorts of applications, or for applications that are served better to be closer to the subscriber ultimately. This edge compute resource. If you think about edge compute, what we mean by edge, first of all, is having this amount of processing that is very close to the subscriber. So the edge is the edge we're talking about is proximity to the actual subscriber in the home. Um, Now, when I think about that with virtualization, and particularly a cloud native approach, you could think about, maybe it's worth repeating what cloud native is first, and then going back to edge compute. So first of all, what we talked about last time is that cloud native, what it means to us is, first of all, containerization, which is how we package the software. Um, Orchestration, we're using Kubernetes basically to decide which container or which pod runs on which CPU resource. Microservices, which is how the software is architected. So you could think about uh, containers and microservice are different. It sounds similar in some ways, that you're breaking up these software components into smaller pieces, but microservices is more about the software architecture and keeping things very clean, modular, orthogonal, and that they could scale independently of each other. All these different services, and the containerization piece is how you package it and deploy it. And then the fourth pillar that we talk about is that it runs on off-the-shelf servers. So when you think about that, all these things, when you deploy a pod, microservices or applications on a general compute resource, that compute resource, where can it live? Well, it could live in a data center on a cluster of servers. It could live in a private cloud. It could live in a public cloud. And then you could think about the other edge of the spectrum. It could live on a compute that lives in a node, or outdoor enclosure, or a server that's very close to the subscriber, and that would be your edge compute. If you have the right architecture, you can have Kubernetes orchestrate and churn up these pods or these applications on this edge compute, similarly to how it lights up and churns up, let's say, DOCSIS service groups in today's virtual CMTS. So you could think of low latency DOCSIS or deep packet inspection or um, different sorts of um, applications that would serve the customer by being closer over there, by having faster response time, by living closer there. So if you have the right cloud native infrastructure, it enables you to deploy different sorts of applications that don't have to be access. They don't have to be access specific. They don't have to be DOCSIS or PON or wireless specific. They could just be applications that live in this compute resource and get deployed as a pod on that general purpose compute.
Okay.
I said a lot of things there,
You
Brady.
did,
I
and
don't know if you want to.
I want to dig into him a little bit here because I think I have an idea of what this edge compute is. But first, I want to know who this Kubernetes guy is. Have you met him before?
No, um, no. It's a great word. Yeah, and sometimes, by the way, you'll see it as K, the letter K, the
Hmm.
number 8, and S. So if
Right.
you see it written, sometimes you'll see that. Um, but Kubernetes is the ability to is a software that enables you to orchestrate and churn up different pods. Um, you don't have human beings
These aren't
involved
like
in.
pod people. These are like software pods, right? These are
Yeah, there's
so
different.
Kubernetes is software that's driving something else. It's
Yes, so Kubernetes is the ability to orchestrate applications. I'm going to use simpler or more layman terms, I guess, that are not so applications. So you have CPU resources. You have a bunch of CPUs running on different servers.
Mhm.
Just to confuse matters, uh, sometimes those are called nodes, compute nodes. Just
but not like fiber node nodes. They're
not like fiber nodes. So just to confuse people, the term node is used in the industry for compute resource as well. So I won't use it in that way, but let's just call them CPUs. So Kubernetes serves a purpose of saying, hey, this application is about to be churned up. Um, which CPU should I put it on? You know, how many resources does this application require? Where can I find these, these memory and CPU resources? Oh, it's over there. It's on that CPU,
Mhm.
and then it'll churn it up
And
and
so
perform that.
Kubernetes is like kind of just keeping an eye on what available CPU, what available resources we have, and then determining where we can deploy these different nodes, these different sort of virtual nodes, right? They're virtual assets that we can deploy and start running them.
Yeah, I'm trying to make sure that it's simplify what we're talking about for the audience. So yes, we don't have to have a human being associate a micro vcmts on CPU 23 on server 5. That's something you don't want human beings involved
That'd be
with,
a lot
right?
of
You want
work for a human being to look around and see what every server is doing and say, "Oh, okay, this server has some extra resources. I'll deploy this little virtual CMTS over there." Right?
Exactly. You want to be able, and you can imagine different applications needing different, having different specs. You know, maybe they need more or less powerful CPU usage or more or less memory, and you want to be able, once you have that spec for that application, and you have something churning up that application, then Kubernetes will then uh, go ahead and assign that application to those set of resources or those CPUs in a orchestrated way, and not having any human beings involved in that. I mean, human beings can go off and find out exactly where that all lives, but they don't need to be involved in actually um, churning up that resource on those CPUs. It's
Right.
automatically done.
Yeah. We just need a superhero called Kubernetes to do all this for us, and it's just
Hmm.
software that does it in the background. So then you also mentioned containers. So like I mean, we've shipping containers and stuff like that, but I think you're talking in the software world for containers, right?
Yeah, and a good way to think about it is a shipping container.
Yeah.
So the term pod, I like to think about it as your unit of replication. So if you think about a VCMTS and you want to have multiple VCMTSs, each VCMTS can be thought of as a pod. I'm generalizing, of course, right? But you could think about it as a pod is synonymous with an application. And an application might have different containers inside of it. So different packages, if you will. So you might have a scheduler. You might have something dealing with control plane messages. You might have something doing ranging. I'm just trying to use common terminology that maybe somebody who's familiar with DOCSIS might be familiar with. So you can have all these things packaged up together, these different microservices packaged up into containers and deployed in a pod. And why is that valuable? First of all, it allows us to break up monolithic software, right? And so it helps with testing. If you're making a change, you can make it to a particular container. You can upgrade a singular container. You could scale containers independently of other containers. So it gives you this flexibility on how you deploy your different services and how you package them, and then how you then install them and configure them.
So the container's
And
just running it's running some code. It's running some software that's doing something that we need it to do in order to make this whole system work, right?
yeah, and I think about it, at least for me, I think about it differently than microservices. I think microservices, you can have microservices and not have containers, right? You can have a microservice architecture and software and deploy it as one big image, or and that would be in I would say in contrast to deploying it in separate containers and then um, churned up as pods by Kubernetes.
Sure. So what's a microservice then?
I think I think about microservice in terms of what it's not. If you think about software that is just one monolithic piece of software,
Like
where
Windows. Windows would be what we call a monolithic piece of software, right?
I, I guess so. I didn't write Windows, but yeah, I guess yes, Windows would be looked at that way, right? When you get a new version of Windows, I guess
You install the whole thing. You don't yeah.
you install the whole thing. You don't install portions of it. So the way we architected things from the very beginning is we looked at things orthogonally or independently. So what does that mean? It means that your scheduler is an independent service from your ranging, which might be independently from your packet processing, and let's say from your SNMP processing. We talked about SNMP and CLI earlier. So
Mhm.
you can imagine that if everything was together as one monolithic piece of software, then then you wouldn't be able to scale or separate those, and they wouldn't have clean interfaces. And if you wrote it in a microservices architecture, then let's say, for the sake of argument, you needed more processing because you needed more data plane resources to deal with higher bandwidth rates. You're basically saying, hey, I don't have more modems on my system, but I need more bandwidth for those modems, right? So the typical thing that grows is I guess there is so we do have growth in subscribers over time on a CMTS, um, but typically the thing that grows the most is the average amount of bandwidth per subscriber. So if you have a microservices based architecture, you can let's say grow your data plane microservice independently from your CLI and SNMP services. Why? Because you'd want to have maybe more intelligent or faster packet processing that's capable of addressing those higher data rates, and not necessarily say, hey, I want to be able to have faster SNMP processing. Those things can then grow and scale independently of each other. Think about it in another way. Eventually, we're working on DOCSIS 4.0. Okay, and let's say the thing that changes there is for the sake of argument, the scheduler.
Mhm.
Well, if you have a microservices oriented architecture, you could then say that that's a modular building block, and that can be taken out and replaced with a upgraded FDX or ESD scheduler, or the component that would need to be upgraded for dealing with DOCSIS 4.0. And and I'm sure that's not the only component that needs to be updated for DOCSIS 4.0, but it shows you that you can isolate the microservices oriented with that new capability, and not necessarily look at all the things that are unrelated in the system, because they won't all be impacted the same. They all won't need maybe more memory or more CPU resources. And that
Okay.
also helps you out with testing as well.
So we're getting more intelligence in our RPDs, in our fiber nodes themselves. I mean, they're like computers in themselves. Does Kubernetes then have the ability to say, "Hey, I have some processing capability out in this fiber node. Why don't I put a pod there?" And maybe it's a special pod, and we can start doing some cool things down in the fiber node itself. Which I think that's kind of what you were describing with your edge compute. We're putting that computational powers all the way down
Hmm.
very close to the subscriber. Is that is that what you're describing with edge compute? We get that close to the subscriber?
Exactly, exactly. And you can have this flexible compute architecture, which allows you to then decide how you use your compute. And you can imagine putting out compute resources to deal with maybe more DOCSIS processing there, maybe some PON processing there, maybe think about wireless processing that's there. So you can decide how you use your compute, and it doesn't have to be specific again to addressing just access. It could be related to dealing with packet inspection and doing special sorts of um, low latency capabilities, and using those resources in that way. So the moment you're able to, um, uh, what we're trying to say is, um, Kubernetes can then light up different applications regardless of where those exist. It's all managed, uh, I would say, in a unified way, and isn't siloed off. It's not purpose built. It's not custom, and that really allows us to address the flexibility of where you want that compute, whether it lives close to the data center, somewhere at the head end, or very close to the subscriber. It's still managed in the same way.
Well, it seems like that gives you a lot of opportunities, not just within your own organization, but also to do things with third parties, or because these are just now become containers
Yeah,
and can get deployed. So are you doing things in that area?
yeah, that's a great point you bring out, and it does give you opportunities to integrate with third-party containers or third-party pods, or workloads, and put them on these general-purpose computes that are orchestrated on this cloud-native platform. So we're actually in lab trials with this virtual OLT, and also with wireless workloads, working in concert with DOCSIS workloads, which we talked about. We have a lot of deployments around that globally. So lots of progress around that with our own workloads, and then working with third party workloads as well. And it's only, I would say, scratching the surface on working with third party workloads. Um, but that's definitely an advantage when you look at going forward. By the way, a third party workload that we could think about could be related to uh, PMA
P&M.
or PNM, or
Yes.
low latency, or I mean, we're all working on different things, and we could see how those things orchestrate and work together.
Yeah, because I think what's interesting about that, and you mentioned low latency or even PNM. So many of the things that we do today, the way we do things today, is we have to take all the subscriber data, bring it all the way back to the head end into the data center, process it there, analyze it there, and then make decisions there. But being able to do things right, the closer we can do it to the subscriber, um, that means we could analyze data at the RPD and make decisions on that data. Some of that data we wouldn't have to bring back to the data center. We could just discard it right at the RPD, or maybe we want to make actions right at the RPD. And then I think we could, looking even further ahead into the future, modems have a lot of compute power on them. And so
Mhm.
we could even extend this past the RPD and start saying modems could become the next edge compute device. So I don't know if you guys are even thinking about that, but that becomes the next exciting realm for me from a a P&M standpoint, and a monitoring standpoint, and analysis standpoint.
Yeah, and what I agree with all that. The opportunities are limitless. I don't know. I hate using these words that are kind of open ended, like everything's future proof and limitless. But really, the opportunities are well beyond what we're thinking today. But what's the key um, fundamental thing that all this hinges upon? Is you have to have a virtualization first approach. Things have to be cloud native to allow us to leverage those compute resources, orchestrate, configure, monitor them in a unified way, and be able to flexibly use those resources and all these different sort of applications. Um, and so it's really this approach, this virtualization approach, that enables all this potential in the network. So that's why we talk about virtualization first, and with virtualization, really anything is possible.
Yep. All right. We're getting close to the top of the hour. I want to take a question from the chat room. It goes back to the daisy chaining of fiber nodes that you talked about, and Tamaz asked, "Do you think about Ethernet ring instead of daisy chaining with your fiber nodes, with your RPDs?"
Well, you can have an open loop or a closed loop daisy chain, right? So I think with an Ethernet ring, we're thinking about a closed loop infrastructure potentially, which could have different capability of protection beyond just extending the fiber and then connecting multiple RPDs in an open loop daisy chain. You can then close it and create a ring. Um, and then you can protect the fiber links, maybe the switches that they connect to above, whether it's the same DAS switch or separate DAS switches. And you could then look at potentially how that connects back to different sites. Those are all potentials with that sort of architecture when you're able to daisy chain uh, conceptually.
So basically, you support either. You can do daisy chain, or you could close the loop on that in case the fiber gets cut. Is what you're saying?
Yes.
Perfect. Perfect. All right. Asaf, is there anything you want to plug coming up for you?
Yeah, sure. As we continue down the path of our journey in cloud native virtualization, Cable OS is our solution, Harmonic solution, to address these different sorts of applications like virtual CMTS, obviously, and as you heard, we're also working on virtual OLT and working with wireless applications as well. So please, if you want more information, come to Harmonic's website, look up our cable access, cable OS information page, and contact us for more information. You certainly can contact me, and we'll be happy to answer your questions and find how our solutions solve your challenges today and into the future.
All right. Asaf, thanks so much for your time today. Great content, absolutely fantastic. And I do want to mention, I noticed a great change in your lighting today. So great job
Thank
on
you.
your side. Upcoming episodes for us on September 11th, we have our next standard podcast. I think it's episode 64. September 25th, we have another podcast. SCT Expo, October 14th. Want to make sure everyone sees that, and that's in the links in below. And remember, SCT Expo this year is free for everyone to attend, so strongly recommend everyone do sign up for that. And also, the latest issue of Broadband Library has just now become available, so please drop into broadbandlibrary.com and catch the latest episodes or the latest articles from everyone, including myself. Thanks, everyone, for tuning in. Please do hit subscribe and catch our latest episode on your favorite podcaster. So long. Goodbye.